All right, up next to talk about the future of cybersecurity is Anthony. He's in from Chicago and he's with Checkpoint.
1 second here. There we go. Excellent. All right, I am battling a cold, so I will warn you up front. So if I stop to take a drink or walk off stage to cough or something, that's nothing to do with you guys. Excited to be here. That's actually my first time at GrrCON. I've actually heard a lot about it. I know I've known a lot of people that have come to GrrCON, so I'm actually excited to be here and actually see it in person. What I'm going to talk about for the next 45 minutes, hour or so, is some of the trends and some of the things that we're seeing as we look at the future of cybersecurity and how we all as security professionals are going to need to attack this and have a sustainable security posture within our organizations to be able to handle some of the newer threats and some of the automation, some of the things like IoT that were just talked about. I'll look at it from a different perspective because I'm not smart enough to know at the chip level how things work. So that's why I work for a software company. But we'll talk about those things, and we'll talk about some of the trends in the market that we all have to take a look at. So if we look at over the last few years, some of the disruptive business models that are out there. You got Uber. I'm sure everybody's used Uber at least once in their life, if not twice a week. They're the #1 taxi company. They don't own a single car. Airbnb. They're the biggest accommodation company in the world. They own 0 real estate. They're basically app developers. Facebook. They're the #1 media provider in the world, yet they create no content. You can argue whether they do or not. That's a political argument we won't get into. Things like Netflix. They haven't laid a single cable. They're providing content, original content, but they're not as part of the infrastructure. Alibaba, they have no inventory, and they're the biggest retailer in the world. Amazon does a little bit more from a retail perspective. But if we look at these organizations, they're selling billions of dollars per year, and essentially they're created an app. And they're selling billions of dollars a year, and it shows the speed of business and some of these disruptive technologies that are able to give people this fast type of movement within the environment. And we'll get to how this all relates to a security perspective in a second. In 2016, the sales of cell phones, smart devices overtook desktop sales. And that trend is going to continue to go. I do more work on my phone than I do on my laptop. So we're starting to see a shift in the environment. WhatsApp has taken over voice. There's more WhatsApp usage than there is actual cell phone usage, phone calling usage. I have 4 kids. I think I've talked to them on a cell phone probably twice in my entire life. It's all done through apps and FaceTime and things like that. Social media has taken over for the source of news. Nobody's sitting down at 6 o'clock or 5 o'clock or 11 o'clock watching nightly news anymore to get their information. They're getting it in real time via Facebook, via Twitter, via all the different social media apps out there. The infrastructures that we all have to deal with have grown and spread out, and we have many, many different things they have to deal with. Cloud, IoT, mobile, all the virtualization that's going on. So how do we keep up with this from a security perspective? All these disruptive technologies, all of these ways of doing things faster, better, cheaper, more scalable, gives great opportunity for people to create businesses and services. So again, as you said, Uber is just an app. They don't deal with the cars, the maintenance, employees. They're just an app. But it also opens up, with all these different attack vectors, many, many different ways for people to attack and exploit all of these different technologies. So if we look at what's going on in the marketplace, security is one of the biggest concerns to IoT adoption. We saw about a year ago, kind of that denial of service storm that was used against IoT devices. We've just done some recent research, which I've been traveling all week. This is my 4th time zone in 5 days. But we're seeing another storm brewing that's going to possibly eclipse the denial of service attack we saw about a year ago in the IoT world. So we're starting to see some that brewing and some of that stuff happening out there. So there's more to come on that, and I need to research that myself. I just haven't been around to look at it. The cloud adoption. There's a lot of security concerns around cloud, and I think a lot of people within organizations, I think the security professionals understand it. Excuse me. But the organization, just because something's in the cloud doesn't mean you don't have to secure it. Doesn't mean the data doesn't need to be secured. Doesn't mean it doesn't need to follow the security concerns of your organizations. And we're also looking at the impact of security attacks. Lloyd's of London, one of the biggest insurers in the world, they probably own about 20 to 30% of all of the cybersecurity policies out there today. They're talking about the next cyber attack costing as much as one of the biggest natural disasters we've had in North America. Looking at things like autonomous cars. I just had this conversation with some folks that do some car work just over at our booth a couple minutes ago about the security around autonomous cars and how it's very difficult. Same thing in the IoT world in the last presentation. You can't just update stuff on the fly. These are things that have to go through regulations. You can't just it's not a cell phone and the latest version of iOS or Android is out and you update it and you go. This is the biggest risk within the autonomous cars, not just the self-driving cars, but all of the different services that cars are providing today. When we've all seen the Jeep hack where people have been able to control the Jeep and that kind of stuff. This is going to become a bigger problem. One of the other things that we've seen, and these are some older information, but when attacks happen within environments, it's taking us as an industry way too long to identify that. An average of about 5 months to identify an attack. So during that 5 months, that's where the damage is being done. So being able to look at security from a different way, to be able to stop these ahead of time, be able to have the right systems in place, the right security policy in place, which is more important than the individual solutions that you have in place for that. And the weakest link in the environment is our mobile devices. This might be a little skewed because we're all security professionals. How many of you have some type of security solution on your mobile phone? All right, so without my glasses on, I'll roughly say probably just under half. If you poll a room full of people that aren't security professionals, that goes down to about 10 to 15%. So this is becoming the biggest attack vector within the environment. We've done some research with mobile phones. And any organization that had more than 5,000 devices in their organization, 100% of those organizations had malware on their phones. Whether it's iOS or Android, we could talk a little bit about that. Android's a little less secure than iOS. We had jailbroken devices, and then also man-in-the-middle attacks on phones is a huge issue, just because of some of the ways excuse me, the phones automatically connect. And we'll talk a little bit more about this. If we look at kind of the first half of 2017, and I didn't add the most recent ransomware attack that kind of hit us yesterday into this presentation. But if we look at what's happened sort of just in the first half of 2017 from an attack vector standpoint, we've now got nation-state tools in the hands of attackers with the WikiLeaks, the Vault 7 releases, and starting to use that information that was private before that to create attacks. So if we look at WannaCry that hit us, or WannaCryptor, depending on what you want to call it, that hit us a few months ago. Excuse me. It was actually a very poorly written ransomware solution. When people actually tried to pay it didn't actually work. It had a weird kill switch in it that you could actually just kill it. But the one thing that WannaCry did very, very well was its lateral movement by exploiting the SMB vulnerabilities within Microsoft that were disclosed via the Vault 7 release. And then not too long after WannaCry, we had NotPetya, which is a better written ransomware attack, and did a lot of damage mostly in Eastern Europe. Luckily, in the US and North America, we have not yet been hit by a massive ransomware attack, but it's just a matter of time. These tools are out there and being written as we speak. There's the latest ransomware attack that, again, I've been traveling, so I've only read like one article on it, so I haven't really gotten too much up to speed on it, on exactly what's going on with that. But we're starting to see more and more of this, and we're starting to see, they're not trying to exploit stuff, they're just trying to make money. They're creating these ransomware attacks to make money. I mean, they don't have any other objective in place. And when there's money behind things, they become more sophisticated. We're starting to see attacks in adware and malware, and this is all just in the first 6-7 months of 2017. Is we're starting to see people using malware or adware to inject malware into organizations, and using these attacks to not only redirect ad revenue to actually make money, but also to use the malware that's embedded in adware, which is something that you usually just ignore, unless you have a adware blocker. But it's usually things that you just ignore, but actually being able to inject malicious code that is then using it to download remote access Trojans, again, redirecting ad revenue. I believe, Fireball itself generated about $2 million worth of fake ad revenue that was then gone back to the people that have developed it. Humming Whale was based off the Hummingbird attack, which is an exploit against Android phones, and using, again, the adware to inject the malware, download remote access Trojans, actually root the devices and take control of them, and do any number of things once you've rooted a device. We're also starting to see macro-based exploits. Interesting one is hover mouse, which was most of the time to get to this adware, to download this malware, activate the malware, you had to actually click on a link. Most of us ignore adware, and usually most of us in this room are smart enough not to click on links that we don't think are bad. But with hover mouse, it used some macros in PowerPoint that if you just ran your mouse over the hyperlink, it would actually execute it and actually detonate the malware. So you didn't even have to click on it; you just had to move your mouse over it, and the macros within PowerPoint would actually inject the malware because it was actually executing the link on that. And then we're starting to see a lot of attacks, specifically in the Google Play Store, against mobile banking apps that have malware written into them, and then using them in valid apps to be able to steal money. So the bank bot, and then there's kind of an issue in Google Play from a security perspective. iOS is a little better, but not immune. Last year, there was a library, the Xcode Ghost attack. So there was a library that was used to develop mobile apps, and people injected malware into that library, and then legitimate app developers used that library to be able to create their legitimate apps, but then had this malware built into it that allowed you to root iOS devices. But iOS's store, the Apple Play Store, has much more stringent security controls and apps, and actually people actually look at it and update it, where Google Play Store is much more open and much more vulnerable to putting in apps that have malware. But from the first half of 2017, we're seeing a lot of trends as far as ransomware, using adware as your attack vector within to insert the malware, exploiting macros, and then also taking advantage of Google Play Store from an app perspective. So some of the issues that we run into really have to do with scale from a security perspective, and we'll talk about some of the strategies of getting around this. But just the sheer number of touch points that an organization or people have to protect is increasing incredibly. I've been in the security space since the mid 90s. I worked at Arthur Andersen for my first job out of college. And it was, people had a PC, maybe the executives had a laptop, and then there was a bunch of servers and data centers, and that's what we had to protect. Now we have, endpoints, we've got tablets, we've got phones, we've got people bringing their own devices, which not only have a security concern, but also have a legal concern of what do you need, what can you do to those devices. We're also looking at things like operational technology, not just IT, your email servers and your web servers and your database servers and your internet servers, but also looking at protecting devices that need connectivity that aren't traditional IT stuff. Working on plant floors, working in oil and gas industry, working in the manufacturing industry. Of these devices need to talk to each other. They need to upload information. They're not your traditional PC server cell phones. These are flow meters that have an IP stack built into them. How secure is that? How updatable is that? So just the sheer number of devices that can provide the attack vector have increased. And then you add in things like the cloud, and we'll talk more about that, whether it's private or public cloud, whether you're doing things like VMware or Cisco ACI, which we'll talk about a little bit, but also just all the public cloud providers and all of the different types of cloud services. Of a web server comes up, it can come back down in 10 minutes, you still need to protect that. You don't have the time of going through and putting all the security controls around that. We also have an issue of scale within the threat landscape. On a year-to-year basis over the last 5 or 6 years, we've seen about a 40% increase in threats, and we've seen about a 9% increase in spend within those organizations to protect against that. Not that those need to be equal, but we're obviously seeing a huge increase in the number of threats out there that people need to protect against. And then if we look at it from a DevOps perspective, and this has a lot to do with the speed of business stuff we just kind of already talked about. Some of the shadow IT, I've worked with a lot of organizations that people need a testing environment or a staging environment, so they're like, well, we're just gonna get an account in Amazon and we're gonna run our testing and staging up there because it takes forever to get a server to test on. I don't have to deal with the IT folks. I'm just going to do it up there. Or also just being able to react to the speed of the ability that cloud solutions give you to be able to bring up and down servers, devices, but you still have to have those as part of your security policy. If a server exists for 10 minutes in the cloud, you still need to protect it. There's still data on that server. There's still services on that server that need to be protected. And then what we see in a lot of organizations is just the number of different security solutions that they have that are very disparate. I walked into one organization, they had 15 different things on their system tray from a security perspective. Excuse me. A lot of people looking at just detecting and not preventing in some very, very easy ways that we'll talk about. And just having disparate security controls that aren't talking to each other. If we look at most security breaches out there, something's catching it, it's just that no one's paying attention. Nothing's talking to each other. If you look at, you go back a couple of years to the Target breach, it was done via, an HVAC network that someone was coming in doing some services on. The malware was injected into that and then obviously spread within the organization. They had security controls in place to catch that, and it caught it. It was detection only, it wasn't preventing it, and they didn't have it integrated with the rest of their systems that people didn't see it and weren't able to react to it. And then we just have the infrastructure diversity out there. So we've got all the different cloud solutions. So infrastructure as a service, so just using things like Amazon and Google Cloud and Microsoft Azure to provide an infrastructure for you to run your servers on. You have that dynamic capability. You have the platform as a server, which is again still the same cloud providers, just providing you more of that service where you're just dealing with the application at this point, not so much the server and their operating system. And probably one of the biggest concerns is these are kind of easy to put security controls around, but you have software as a solution. You have all the different software solutions out there that still are holding data that needs to be protected and needs to be secured. So, things like Salesforce, Dropbox, anything out there that organizations or you may be using, just because something's in the cloud doesn't mean that the security doesn't need to be controlled around that data. And again, we'll talk about more of it. And then nothing as a service, kind of the traditional data center route. Most organizations are doing all 4 of these things at the same time and still having to deal with the security of the data and the services and the availability of the stuff running in this. If I have financial data and it needs to be secured, it doesn't make any difference whether it's sitting in a Dropbox account, whether it's sitting in a server in the cloud, or whether it's sitting in a data center or a laptop or an endpoint. I still need to be able to secure that data regardless of where it is in the environment. And then again, just keeping up with the malware gap. Traditionally you go back 10, 15, 20 years, antivirus was enough. It isn't. And we look at the way malware comes and we can hash it. Malware has gotten very, very smart that it self-changes every minute or so. So just hashing things doesn't work. Taking a file and seeing if VirusTotal knows about it is good if it's a known thing. But most malware campaigns change the file enough that just straight up hashing doesn't work. So we're only seeing malware once. And this really affects how we have to approach security within our organizations. Okay. So what we look at, is people putting in security controls, looking for threats, obvious threats that they can identify, and then adding more and more security controls within their environment that again aren't talking to each other, that are disparate security solutions. Not only does it make it cost ineffective, but it's also from a security perspective, it's not effective to have 10, 15 different products that aren't talking to each other and finding things on their own. So being able to have a single integrated security system, I'm not just saying a single vendor solution, but having a system that allows you to roll up everything from a SIM perspective, a logging perspective, a configuration perspective, being able to look at it as a whole as opposed to having all these different mini point solutions out there. And then again, also focusing on the prevention aspect of it. I don't know, you've all seen that LifeLock commercial. LifeLock's now owned by McAfee or Symantec now, I think. But like someone's coming in to rob a bank, and there's like an old dude in the corner who's like a security guard, and he tells people, "Hey, you're being robbed." And they're like, "Aren't you going to do anything about it?" And he's like, "No, I'm the security monitor. I'm just here to tell you that you're being robbed. I'm not here to prevent it." So we all need to focus on the prevention of it. We need, you need the big WWE wrestler out there with a AK-47 protecting it, not some old guy who's just going to tell you you're being robbed. So this is what we all need to focus on, is the actual prevention of malware. Everybody familiar with the Lockheed Martin kill chain synopsis of sort of security? They came out with this 6 or 7 years ago, I think, maybe a little bit longer. And what they look at from a security perspective and an attack perspective, everything starts with some kind of reconnaissance. You got to remember, Lockheed Martin came from the physical, war machine world. So they trying to compare this more to what's, out there from a land-based war perspective. But every malware campaign, every type of attack always has some kind of reconnaissance. Whether they're looking for their targets, trying to identify the targets, whether they're just defining they're just going to go after as many people as they want. Most of the ransomware out there is targeting financial and healthcare firms because they're the ones that'll pay it. You bring down a hospital, there's lives at stake, they're going to pay it. In fact, when I think it was WannaCry hit a hospital, they brought in a security consultant, and he said, for, whatever it was, $500,000, I could get rid of this in your environment. It's going to take me a week. Or he goes, or you can just pay the hackers $300,000 and have your stuff back up and running in about 30 minutes. So his recommendation was just pay the hackers if you want to get your stuff back online. So the reconnaissance may be, let's try and find out how we can target the healthcare and finance people, whether they're scamming LinkedIn, whether they're buying lists, all those types of things from a reconnaissance standpoint. It could be some network reconnaissance of looking for vulnerable things out there. Very similar, like the denial of service attack that was used against IoT stuff last year. They went out there and scanned and tried to find all the vulnerable devices before they launched their attack. They didn't just launch it at 10 billion different devices out there. They did scans for, who knows how long, months, to be able to find the vulnerable devices, and then went to the delivery stage of being able to deliver the malware, deliver the attack. And then that delivery of it is, done via multiple ways. It could be done via automated scripting or, hacking. It could be done, via email. It could be done via, command line injection of websites. Any different ways of delivering that. And then you have the exploitation, the actual, sort of detonation of that malware to do what it's supposed to do. Whether it's ransomware, whether it's to root a device, whether it's to steal information. You have the actual detonation of that malware. And then you have the control of it, which may be lateral spreading, which is the one thing that WannaCry was very good at. Once an organization was infected from the outside, the lateral spreading of that malware was fairly impressive. And then you also have the command and control back to whoever's controlling this. Obviously, if it's something like ransomware, there's somebody on the back end who needs to determine whether you've given them money to unlock the device, whether they're trying to steal information. There's somebody outside the organization that is receiving that information. So again, you have the ongoing command and control. And this is why we see attacks go months without being noticed. Because if they're really good at this part, they're not going to know that something's going on. And we need to look at security from blocking it at every stage of the attack chain. So looking for that reconnaissance, which is the hardest part, but then also being able to block the delivery of it, and we'll talk about some methods on how to do that. Being able to contain the exploitation if you do get to that point, and then also looking for the ongoing, command and control of that malware. So, most malware isn't a one-time thing. It's an ongoing thing that is again, trying to, either steal information, use that device to launch denial of service attacks, like the denial of service storm that we saw a year ago using IoT devices. The malware was injected and then it was controlled by somebody, and then they were able to, at one time, be able to activate that malware and control those devices to do the denial of service attack. I am a big fan of this quote. You can always trust a dishonest man to be dishonest, but it's the honest man you should not trust because you never know when he's going to be dishonest. If I know people are bad, I'm not going to accept information from them. But if I'm, in the most part, trust somebody, I'm going to be more often to take information from them. So we need to, look at these sources of information. Again, the honest man may not mean to give you malware, but that's going to come in from those sources, and it's going to come in from, known dishonest sources. I get, we've all gotten spam email that is usually malware. They're not actually trying to sell you male enhancement pills or sexy singles in your neighborhood kind of stuff. There's malware embedded in that. We all know that. I'm not going to open that stuff because I know that it's a scam of some point. But if I get an email from somebody I've met at this conference, I'd still be a little apprehensive to open it, just because it's a security conference. But we have some type of personal relationship, or someone found me on LinkedIn or Facebook or Twitter or something like that. I may be more apt to accept that email or that document. So this is what we need to take a look at. Was about I don't have my glasses on, so I can't remember when this was. I'm going to say it's 2014. At the RSA conference, there was a panel discussion around security, and and talking about security the old-fashioned way is passing the known good. Is let's just figure out what's good and allow that in, and let's just block everything else. It's a simple concept, but it actually works, and we'll talk about some of the newer technologies that are available today to make this much easier. This is something that the NSA is doing internally in their own security environments. So how do we look at it? We can just take files and information that we're getting, and we can sanitize it. It's low cost, it stops the bad, it passes the good. I get information, I don't care who it's from. I'm going to remove anything that's possibly malicious from that file, and then I'm going to deliver it. And then I know that that file's clean. Now, I may have removed some properties of that file that I may need, and there's some ways to go back and look at that. But in most cases, if I'm an HR rep and I'm getting a resume, it doesn't need to be macros enabled in that Word document. I want to see the information, maybe there's a hyperlink to something, but that's all I need to go. So I'm just going to remove anything that could possibly be offensive to that. So, so the file flattening, sorry. So again, being able to remove all of the active content from information before you deliver it. Converting files, just rewriting them from like Word to PDF, very simple to do, very cheap to do, and being able to prevent a lot of attacks there. Again, removing the macros and dynamic content. And we're also starting to see a lot of malware being embedded in images and video files, of actually being able to use tags within the different formats to say, hey, these pixels in this images should be executed as a macro. So that exists within the audio video world. So again, just being able to remove those tags. If I'm getting a picture of a cute cat playing piano on the internet, I just want to see the cute cat. I don't need my browser to implement a macro that's embedded in that file. So again, just cleaning out all the different attack vectors, regardless of whether there's malicious intent. It's very quick to do. It's very easy. It's very inexpensive, and it's super effective. Yes, there is a downside. If I may need some of that active content, then you can go back and do further security on that. So again, we can look at things like image purification, being able to just rewrite the image and remove some of the macros that exist within the image files to be able to execute code, and then just taking, regular files. I mean, stenography's been around forever, hiding information and other sources of information. Just being able to remove all of that. Doing the inline extraction that we talked about of removing dynamic macros from files before they enter your environment will stop, I don't want to say 100%, nothing stops 100%, but it'll stop a lot of different types of attacks out there. And again, it's very cheap and very easy. Excuse me for 1 minute. I'm surprised my voice has held out this long. So if we look at building security architectures within the organizations that meet the future IT and OT architectures out there, is that if we look at sort of the software-defined networking world, which everybody's moving to, whether it's internal, whether you're using public cloud, private cloud, implementing things like Cisco's ACI, using things like VMware's NSX, we need to have a security policy that's in tune with that. And what we need to look at is look at our security for our organization, whether it's data security, network security, application security, and look at it in sort of 3 different layers of looking at a management layer, and we'll get into each one of these, that has the modularity, the visibility, the orchestration within your environment. And then having a control layer, which is doing all of your dynamic security updates. As we said, security is obviously happening, very, very quickly. There's updates to all of your security systems that you have that need to be able to be updated on a real-time basis that are, again, applying it to your policy. And then you have your enforcement layer, which is the actual piece of, the actual point to where you're actually enforcing your security, but it's probably the least important of it. So whether, and we'll get into all of this, but, whether it's an endpoint, whether it's a perimeter gateway, whether it's an internal gateway, whether it's a cloud infrastructure, whether it's APIs into a SaaS infrastructure that you're applying security to, the enforcement points are the least important part of this, because once you do this part right, the enforcement points are just doing what they're told to do. And what this allows you to do is take information, like I said before, I have financial data that needs to be protected. So I have a security policy that says, only these people can get to it. It can't, it needs to be, secured or encrypted, all that kind of stuff. It doesn't make any difference where that piece of information lives. I don't have a specific security policy that if this information lives on a database server in my data center, then it gets this security policy. Then if it's sitting on a Dropbox account, it still needs that same level of security. Or maybe we don't allow it to go to a Dropbox account. But we need to have that same level of security regardless of where it is. So the enforcement point, again, is meaningless. Not meaningless, but it's the least important of all of these. So again, your enforcement points could be anything, internal virtual systems, they could be cloud security, they could be mobile security, could be network security, could be endpoint security. If that file existed on my phone, it still needs the same security as if it existed in my super, private, data center, database server, sitting in my data center, or if it's running in the cloud. So we need to be able to have that security that follows the information as it goes within your environment. And obviously, as networks are changing, we're no longer have these separate physical networks that we can protect against. Obviously, with the advent of virtualization, which is good, which allows us to be a lot more agile. But with the advent of all the cloud technology, whether they're public or private, and some of the SDN technologies out there, physical servers or physical applications are going to be existing in millions of different places, or potentially millions of different places. So we need to look at, sort of the micro-segmentation of our data applications and servers within the environment. So, creating things like atomic segments that are, segments that share the same security policy regardless of where they are. And then grouping those segments together so you can provide security based on those groups, regardless of where they exist. And then doing some of the, consolidation and talking about the data flow between those segments. So again, doesn't make any difference physically where things sit, but if this is a server that has to be HIPAA compliant, or this application has to follow the HIPAA compliancy, it may not be able to talk to other portions of other applications and devices on your network or within your organization, but they physically may be connected to the same switch in your data center, or they may be sitting in the same cloud instance. So we need to be able to control the flow of information between the different groups and segments. And then again, creating those trusted channels. If I need to talk to my cloud environment, how am I doing that? How am I securing that information? How are my endpoints getting into these different environments? Very few people are sitting in an office behind a PC connected with a wire under their desk to a hub that goes to a switch, and then you have a big data center in the office that you're going to. This information is incredibly spread out. So if we look at it from a micro segmentation perspective, again, being able to define a DMZ server that's exposed to the internet. It may not actually be sitting on a separate interface of some type of perimeter gateway hanging off of a switch in your data center. That could be a cloud-based service. It could be a server that happens to be somewhere else in the data center. But it's considered a DMZ server, meaning it's exposed to the internet, has different security controls for it. How do you separate your users? That user's a user regardless of whether they're on your LAN, whether they're coming from a mobile device, or whether they're accessing cloud information. And then you have things like data center servers, departmental servers, sensitive information. We see this a lot with HIPAA compliancy. Is that certain HIPAA information can't talk to other devices that aren't, or other servers and applications that aren't HIPAA compliant. And traditionally you go back 10 years ago, and there was a section of everybody's data center that had to do HIPAA stuff. Like, this is all my HIPAA stuff. And you had separate security controls around your HIPAA stuff, and nobody else could talk to it. And that's all that had to be HIPAA compliant. When you get into things like public cloud and Cisco ACI, and you get into things like VMware NSX, the HIPAA server may be sitting right next to physically a server that isn't HIPAA compliant or doesn't need the HIPAA compliancy. So with the SDN technologies, and now looking at this from a software security perspective, we're able to provide that segmentation of those services without having to physically separate things, and it's actually pretty powerful. Excuse me, I'm sorry. And then if we kind of look at the control layer, this is where we're generating protections in real time. Whether it's your IPS product feeding, IPS updates, or whether it's some type of, advanced threat protection product feeding in updates, whether you're getting feeds from other sources, whether you're creating your own security controls and updates, being able to have a single place where all of this is consolidated and then shared with your actual enforcement points, your places where you're actually providing the security. And being able to look at it from multiple different layers. When you look at security policies in general, you're looking at things like access control in general and data protection. So you have who and what can go where, and then you have what kind of controls do I put around this specific data, which are kind of two main separate types of protections you need to put around. And you have that feeding into your enforcement point. So whether, again, it's that file that always needs to be encrypted, that only people in the finance department can get to it, being able to have that control exist within that file regardless of where that file is. Again, whether it's sitting on a cloud service, whether it's sitting on my phone, whether it's sitting on my laptop, whether it's sitting in a super secure database server in a data center. And then you have your access control policy, which is saying who can go where, what can go where, who can talk to what, and being able to enforce that regardless of what the enforcement point is and where that data or that access is going. Excuse me. And then more importantly, as we move on to the management layer, and this is really where a lot of automation comes in, which is how we're going to have to do this to deal with the speed of security and the speed of business that exists today, is being able to have your management layer create the security policies that are, again, using the controls and the automatic updates that are coming in from here, and then applying them at your different enforcement points. And we'll talk a little bit deeper here about the management layer. So if we look at the management layer, it's really the orchestration of it. So we have all these different places where security needs to be, whether it's public cloud, private cloud, data center, endpoints, mobile devices. This needs to be automated from an orchestration standpoint of being able to automatically identify when different pieces come up in the environment. As I said, when I go to my AWS server farm or whatever you're doing up there, and I want to create a new web service, it takes me 2 seconds to bring up a new web service. Or just from an auto scaling standpoint, I have a web server farm running in AWS or Azure or Google Cloud. It doesn't really make any difference. As that thing scales, it may automatically create multiple instances of that web service or application to meet your load. You need to be able to get that real-time information into your management environment and then be able to post that out there. So if you have rules that say, these database servers can talk to these web servers, if you have web servers popping up and going down every 10 minutes with your environment because you're using auto scaling or you're using cloud functionality, your security needs to be able to be aware of that and apply that in real time. You're not going to have, someone open up a help desk ticket to create a firewall rule or an access control rule to be able to do that. You need to be able to have your management layer orchestrate all of that. And then also be able to kind of bridge that gap between your very agile cloud virtual environments to your more static data center environments. So again, having, if your database servers are sitting in your own data center, but you need to talk to your web servers, and those web servers are popping up all over the place, whether it's internal virtualization using VMware or whether you're using cloud virtualization, those physical database servers need to be aware of those web servers to be able to transfer the appropriate information to keep that application up and running. So the management layer is helping bridge that gap and take that dynamic and static and make it seamless to the control layers and then also your enforcement layers. And being able to have open APIs that you can integrate other systems into. I've seen a lot of organizations get to the point to where they don't have people creating security policies. It's all automatically generated once they have the overall security policy. And again, this could be a multi-vendor solution. It's just there's a lot of open APIs out there in the security world that all these different vendors or homegrown solutions can write to. But if you look at it from comparing security to sort of the move that we're all seeing in the SDN world, is being able to have your security be dynamic. So most organizations that I deal with are moving to some type of software-defined network. Whether it's ACI from Cisco using NSX from VMware, or even a combination thereof. Or if you look at some of the service providers, really using like the OpenStack concept, which is completely an open SDN infrastructure, and a lot of them are writing some of their own controls into there, but also using some of the stuff that's already out there. You don't see the OpenStack stuff too much in enterprises, but mostly in the service provider market. But being able to have your security mimic where we're all going to from a networking perspective, and having that dynamic, real-time, changing types of networks, and your security needs to be able to follow that. And we're not having that physical separation anymore. We don't know when servers are coming offline and upline. I go back to when I first started in the security world. If you needed a new server, you went to the purchasing department and they bought the right server, and then it came in, and then the server team loaded the operating system and the patches and the backup software, and then it got some name via DNS or whatever, and then the security guys had to go into the firewall and create a firewall rule, and then you had to secure that data. Now if I need a new server, I click something on VMware, or I click something in a public cloud, and I've got that new server up and running based off of a known good image. So I need my security to follow that too. I can't separate things physically anymore. I need to have the security regardless of where that data resides. So I need to have my data security follow the data. I need to have my access control follow wherever those devices exist, and also be incredibly dynamic from a control standpoint to be able to react to the changing environment. We don't have this static, slow environment anymore. We have servers up and running and coming up all over the place. So just kind of a way of defining your security architecture more along the lines of what we're seeing from an SDN environment, a software-defined network environment, having a software-defined protection environment or software-defined security environment, and looking at all of the different attacks and the new vectors that are out there, being able to respond in real time and have the automation to create your security policies. So, all right, we're about 15 minutes early, and my voice held out. So I was a little worried about that. But any questions or comments or things you guys are seeing in the environment from a security perspective? Nope. All right. Well, thank you, and enjoy the rest of today and tomorrow. And I will talk to you later.